Oh, good afternoon, everybody. We just wait a few minutes for people to get into the session. Hi, Uncle Jim and Abby. Nice to have you on the show. Looking forward to hearing.
Hey, Roger.
Hi.
Excited to be here.
Yeah, it's going to be interesting based on the rehearsal. So I'm looking forward to hearing the detail of it. Okay, we've got a good bunch of people trickling in. I'll just give it a minute. All right, slowed a little. So this is the AnDOUC TechCast. I'm your host today, Roger Cressy. I am an associate director with Bravantia, helping them with the US projects. And today I have with me on the show Dr. Abby Giles-Haigh and Uncle Jim Czuprynski. We'll talk more about them and give more detailed intro in a minute. But before we start that, I'm just going to do a little bit of housekeeping. Could you give me the next slide, sir? So the TechCast that we have today, thanks, Jim. The TechCast that we have today is a result of an abstract being submitted on our website. You can see the link there, andouc.org TechCasts. And you'll find an archive of all the ones that we've done. Coming up, we've got Unveiling the Mystery, Beginner's Guide to Machine Learning. That's November the 30th. December the 14th, you've got a panel, which I will be working with a number of our top pods. I think Abby's likely to be on that again. Wayne Van Sluis will be on that. Dan Vlamis will be on that. So, and we're basically going to give you our favorite features of the new 23C OAC. So please do submit your abstracts for anything Oracle around analytics, spatial, graph, Analytics Plus. And we'd love to speak, especially if you've got something that's particularly interesting story, and things that we've actually done at customers that you have done that can teach the organization as a whole, our community. So with that, let's move on. We've got merchandise, and in fact, it's nice to have her on the call today, but Dr. Abby is the one who designed all of these, and they are different to what you normally find. So please do come along and support us and buy the merch. It's good merch. Next one, sir. There's lots of ways of connecting with us. We have, obviously, we've got our website, as you would think. We've got all our archives are on YouTube. We have LinkedIn and another subgroup, LinkedIn Spatial and Graph. And we're on Facebook. We get involved in Twitter, but the most interactive at the moment is actually Slack. You can chat with anybody on the community if they're around, including a number of senior product management. Thanks, Jim. Oh, and Carrie will put those links into the chat. Very important, clear your diary and come and join us in person at the Analytics and Data Summit. We're meeting at Redwood Shores, Building 300, from April the 9th to the 11th, 2024. It's a great way to meet people in person. We'll have a lot of Oracle product management there. And with that, let me carry on and just say one more thing before we introduce our speakers. That is question and answers. Please do use the Q&A icon. Don't put questions in general chat. We have an amazing panel with us today. We've got Jan and Melly in the background and Gina. And they are in the background waiting for any questions that might come up. They're here in support of Abby and Jim. So let's move on. Introducing them, ladies first, because I'm old-fashioned, and you can slap me later, Abby. Abby is the only field CTO that I know of in Oracle, EMEA. She's, there it is. She's all-round brilliant. She's worked across the piece. There's not much that she doesn't know about machine learning. And in fact, generally, I found analytics as a whole. More than that, she's become a friend, and she's definitely part of this AnDOUC community, a big part of it, and actually, in some ways, has been our heartbeat for a long time. So thanks for joining us, Abby. And then Jim, I call him Uncle Jim. I've known Jim a while, actually, from Kscope days, and he really is a storyteller, and it's one of the reasons I love to hear him talk. Today, you'll hear how Abby and Jim take something very technical and put it into understandable bite-sized chunks that functional people can understand. This man is up to everything. He doesn't give up. You'll see, I'm sure he'll give some chats about himself as he carries on in his own introduction. But with that, I'd like to hand over to you both. Thank you so much for coming on and joining us on the TechCast today.
Oh, you're most welcome.
Thank you. Cool. Okay, well, let's get started, Jim. We've got quite a lot of content to get through for everyone this evening. If you're in the UK, you'll probably spot the accent. So good evening to those in the UK. Hopefully you enjoy this with myself and Jim. So let's get started. First and foremost, everyone knows about the multi-model capabilities in the Oracle database. And as you can see, we've got lots of things now available to us in the database. Oracle machine learning, definitely something close to my heart, something you can do a lot of work with. Spatial, there's been lots of presentations previously at the analytics and data user community on spatial. But the one that we're really focusing on today is going to be graph analytics. Now, what we're actually going to look at today is property graph. Now, there are two types of graph inside the Oracle database, the other one being RDF, that's resource description framework, so RDF. We're not going to do that today. We're going to stick in property graph. With that said, next slide, please. And what is a property graph? Yeah, you're good, Jim. You're good. So what is a property graph? Well, instead of me kind of making it too complicated with like lots of terminology and stuff, let's just look at it in this really simple way. If I'm a node, suppose on the left-hand side of that screen, and Jim's a node, we could be connected in various ways. It could be we go for a meal and I pay Jim my half of the bill, so I send some money to Jim. That's a connection. It could be a connection of how many different conferences myself and Jim have appeared at together. So that line could represent conferences where we've presented together, for example. So we recently did Kscope, now we're doing Analytics and Data Summit. So that line could be there in that sense. A graph, though, can be lots of nodes and lots of edges. So straight away, we could have Roger could join us and be another node, and Melly could join us and she could be another node, and we could have lines all over the place and different connections. Next slide. When we really want to use this is for discovering and understanding relationships. So, I started to talk about the types of relationships that you could represent on those edges. And really today we're going to look at customers, accounts, and transactions to try and keep it simple. And that's because you can really start to think about this mentally in terms of customers, nodes, transactions, edges, accounts. Well, actually, accounts could be basically you could count the number of accounts, could be an edge, or an account could be a node. So you've got different options available to you. In terms of what does that look like, well, let's look at the next slide and we can see that if we put those nodes together, we can end up with these chains that happen. So is there any money flowing between Bob and Charlie? Well, I don't like Bob and Charlie, it's me and Jim today. So is there any money flowing between me and Jim? So if we follow that diagram, we can see that it traverses from one node to another node to another node to another node to another node. Oh, and there's Charlie. So Bob passes it to A1. A1 goes to A3, which is connected also to Dave. But A3 goes to A5, and then A5 goes into Charlie. So there's ways that we can do that. But there's other ways that we're looking for information, things like clusters of transactions. So what's common? How do we rank them? What are the paths that are connecting those little clusters? Am I a social butterfly and I'm actually connecting lots of clusters? So I might be part of the analytics and data user group. That might be one cluster, but I'm also part of the K-scope cluster. So I could have a line into both clusters. I could also draw a line to the UKOUG cluster. I'm actually here in Reading at the UKOUG tonight. So, you can see that we can join the links between user communities or clusters. So different ways to look at data and look for those connections between them. If we bring that to a real life example now, and we go into the world of manufacturing, here's an example of how we could put it for the bill of materials analysis. So let's take my car. Okay, so I have a Volvo car, and it's got lots of components. So it could be a seat, a steering wheel, a gear shift. All of those components might have parts. So for example, screws. Part E could be a type of screw that is used on both my seat and my steering wheel. And part E, that screw, also has a counterpart, the other part of the screw that holds it in place, part I. Now, what if we were able to find out that actually the company that makes part E is about to go bust, or can't fulfill an order, or has a problem at the factory? We could use the property graph to identify the components that it's going to affect, so the steering wheel and the seat, but also what other parts go with E. And we might end up with too many part I's because we don't have enough part E's. So very quickly we can find these nodes and what connections they have, so relationships. If we come into the world of transactions, and this is the world of fraud. I love the world of fraud. There's lots of things that you can do in it. Here you can see that if I'm the one bad guy and maybe Jim's the other one, and we want to clean money, it might be that I split my $100 up and I give 10 to Jim, 10 to Roger, 10 to Melly, 10 to Jean, and then they eventually give it to Jim, and we've cleaned the money. So we're looking for ways of looking for suspicious activity. And sometimes that could be circular. So it could be, I'm actually passing it to Jim, to Roger, who passes it on to Melly, who passes it on to Jean, who passes it to me. We could also be looking for layers, so large amounts that suddenly get split, put into different transactions and then brought back together, and we layer them up and hide the transactions. There's lots of things you can do in fraud in the financial services. So there I've described some use cases that the business world use property graphs for, and hopefully you're getting an idea of where that might be applicable in your world. And what we see is that these are relationships, or direct or indirect relationships, that we can actually measure. So we have simple networks that we've described. We've got hierarchies, think of the bill of materials, things like that. You've got paths. If anyone's ever seen me present, I do a property graph with football. So looking at the path of the football from the goalkeeper through to scoring a goal, and what path that football takes. So there's an example. And then patterns. So if you think of those patterns in terms of triangles and finding those circulars, etc., you might be looking for patterns. So all of this we can do in the world of property graphs, and it's a unique way of looking at the data that we can use the database for. So Jim, let's get into our example for today, and financial transactions.
Exactly. And one of the things here, Abby, is we think about this, right? Most of you that know me, I was an application developer, then I became a DBA, and now I'm kind of headed back into the application developer mode here. As I'm going through some of these examples, and as Abby's describing them, think of what the SQL statement might be that you would have to write to find these things, because that's what our main topic, when we get to it in just a little bit more with our demo, is all about. But back to our idea of a relatively simple example, I have a series of bank accounts, going back to Abby's discussion about fraud, right? Notice that the bank accounts table owned by the graph user schema has an account ID as its primary key. Okay. Name could be the person's name, and it, again, identified uniquely by the account ID. Over on the right-hand side here, we have transactions. And note, we've got a from and a to, or a source and a destination. And by the way, that's another thing that's very helpful in graph transactions as we're looking through them, is there's often, not always, but often, a directionality. Think for a minute about social networking, right? I may, in Mastodon, where I am, right? Let's assume that Abby and I are both on Mastodon or both on Facebook or whatever, right? I could be following her, but she might not be following me. And we both might be following someone else, right? So the concept of directionality is crucial in many cases. Anyway, back to this for a minute. We got a from and a to account, a description of the transaction, and an amount. Note that the from, to, and amount columns are the primary keys. And obviously, from account ID and to account ID would be foreign keyed back to the account ID of the bank accounts table. So what does that leave us? Let's talk about how this would be deployed in a property graph data model. Vertices, or as Abby says, nodes. I prefer the word node because the plural is nodes. Vertices, or the singular is vertex, so that gets confusing. Sometimes people say, what are you talking about, vortex? No, vertex. You know what? Node. We'll stick with node. So if you will, in this case, we've got an account and another account and another account. Those are nodes. And then the edges represent the relationship. So there is a transfer relationship between these accounts. Let's put some attributes on top of these. So the account up here at the very top, I have account ID 1, account ID 672, account ID 104. The transfer relationship itself has an attribute, amount. And notice we're passing $1,000 from account 1 to account 672, and then transferring yet again, or moving, $1,090 to account 104. So now try to wrap your head a little bit more around this if you've not seen this before. And by the way, we could also have situations where these accounts have more than one relationship. We talked a little bit about social networks, right? There's the concept of I'm a follower, I'm a following, I'm an influencer, I'm being influenced by, right? So there could be one account, for example, or one person could have multiple edges, multiple relationships with other people in a social network. But we're going to keep this simple. We're going to keep this simple and just have one relationship and one set of nodes. So how does this work in the real world? Let's take a look at this. We've got a bunch of account IDs, right? 1 through 1,000 or something here. And then we've got the from and to account ID, right? Which ties back to the account ID here in bank accounts, and an amount, right? Remember, primary key for this table is from, to, and amount. So the way we would look at this from a relationship perspective is, okay, account 1 is transferring money, $1,000, to account 672. Account 2 is transferring $5,001 to account 833, and so forth. See how this works? So in this case, we would say bank accounts, that table is a vertex table or a node table. Every row in bank accounts is a vertex. Bank transactions, on the other hand, in this case at least, is an edge table. Each row represents a cash transfer, and each cash transfer is an edge between those two vertices, those two nodes, the accounts. From and to, we are transferring funds. So
Jim, can you just go back to that?
Yes, please.
Just go back
ahead, Abby.
slide, Jim. Very quickly, I'm an old school DBA person, and some people might be looking at this and going, this looks familiar. If you are into the whole world of star schemas, you might be looking at that transaction table and going, that's my fact table, and my accounts are my dimensions table. Just another way of conceptually, if you come from that background, seeing the data. While we're using different terminology, just to help cross over some people's backgrounds and just help them conceptually get the pictures here. If we think of that as your fact table and your dimensions, it might just help you picture what's going on under the hood.
Yeah, excellent point. Thanks, Abby. Yeah, exactly right.
Very quickly, Jim, your camera's off. Is that by design? We're missing.
Yes, it is. Well, because I want to make sure for the demo later you can see me. But
okay, no problem. I'll turn off.
I'm off by design. Yes, it is. So, okay. For what the heck? I'll inflict my mug on you for a little bit more. Let's go back over here. Excellent point, Abby. Thank you so much for that. If we look at this from a display perspective, right? We're looking at the first tabularly, but if we draw this as a graph, some interesting things appear. It's immediately obvious that account ID 259 and 387 and maybe 190 and this guy up here and maybe this guy over here and 532. Wow, they're active. They're very active in this, right? Think about this. Another way to think about this would be, what if this was a graph of social media posts being sent out, right? If 259 was a poster, this guy's sending stuff to everybody. He's got followers everywhere. So that's just another way you can conceptualize it. Let me bring it back to financials, though. 259 is highly connected. It has a lot of relationships, a lot of edges. By the way, 259 starts a lot of transactions as well. Oh, and by the way, another point, you see this? A triangle, right? This is one of the things we're going to talk about a little bit later. There is a path back to the original transactor. If this was a money laundering scheme, this might go fraud, 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 right? Because it could be somebody transferring cash to another account, and maybe they're transferring cash, or maybe somewhere along the way, they're selling it, translating it into a different type of property, and then turning it back into cash and sending it back, right? Another thing, Abby talked about paths, right? So here you have account 228 and account 681. Maybe it doesn't look like 681 and 228 are doing anything, but wait a minute, we're constantly seeing transactions flow through these four accounts. That could be suspicious as well. And finally, 569 over here. Well, what's the deal here? I mean, they're not doing anything. Well, let's shift back to a minute for the social networking aspect. Maybe we've poured $100,000 in 569 who told us they were an influencer, and they aren't doing anything to send our messaging out, right? I was just on a call yesterday with a political party here in the United States that was actually talking about, how do we find influencers and how do we get them to do our messaging for us? Well, if 569 is one of my so-called influencers, we're going to have a talk here because you're not doing anything, right? Also, if we go back to our financial transactions aspect, we have pretty well established that 569 isn't really part of any fraud because they aren't doing anything. So that's another way we can look at this. So how would I create a graph for my relational tables? Now, one thing I'll tell you straight up, as a DBA, the first thing that really made sense to me when I was looking through this is foreign key relationships. So remember, we showed you the two layouts there. Bank transactions, that's the name of the table, had a from and a to account ID, which, by the way, is foreign keyed to the bank accounts table. It's account ID. So that's one of the ways that typically, not always, but edges and vertex tables or nodes are typically related. Not always, but they can be. They don't need to have a foreign key relationship necessarily, but it helps for other reasons. Also, let's talk about this create property graph statement. I'm creating a view, really, truly a view, bank graph. Key point I want to emphasize here, I'm not creating a materialized view. I'm creating a view for all intents and purposes, very much like a view. This is really great, especially when we're doing operational workloads, possibly a DML plus a query. So here, the bank transactions table is the edge tables. Bank accounts is the vertex table, but note I can label it something different if I want. I can just say accounts instead of bank underscore accounts. See that? Oh, and by the way, nodes and edges can have properties. What if the accounts table has 75 columns? For my analyses, I only care about 2. What about here? Maybe this one has 100 columns. I only care about amount and description. So that's the essence of what a property graph statement looks like. And now things get interesting. Back to you, Abby.
Yeah, so Jim's essentially showing you how to create the graph. Now, once we've got the graph, the best part of all of this is that really we want to query and analyze and find some cool insights from it. That's really what we're here for. So there's just some like basics that we need to just learn about our syntax that we use when we're working with property graphs. So the first one is the nodes, me and Jim, if you like. If we go back to our beginning diagram, we are the curved brackets, the curly brackets. And the money that I'm giving to Jim, that's the square brackets. That's the edge. So if we look at the top of it, the first one on the left-hand side, we're going to select A, me, and B, Jim. Hi, Jim. And we're going to look for all the transactions from match. And we can see A is in the curly brackets, so it's referring to a node. E is the edge because it's in the square brackets, to B, a node that's in a circle bracket on graph. And the graph is what Jim just showed us how to build. Now, notice the difference between the one on the left and the one on the right. On the left, I've got no arrows involved. So it can be any direction, non-directional. But on the second one, we're saying that it's transferring to Jim because we've got an arrow in place. We can be a bit more specific exactly what we want in those nodes. So the nodes could have had account or names. What if we want just it's an account, is account? So you can see here now that A is account, E is a transfer. So I'm not looking at the description, I'm looking is transfer. And B is another point that it can be. So that's another way of doing it. The next one down is where we get a little bit more complicated. So far we've got curly brackets for nodes, square brackets for edges. Jim, we've got a new one, squiggly brackets. So squiggly brackets here is a 1-3. What we mean by that is there are between 1 and 3 hops between me and Jim. So if I was moving money, I would be looking for anything where I'd passed it to Roger and Roger passed it to Jim, or I passed it to Melly who passed it to Roger who passed it to Jim. So we have hops. So how many nodes between me and Jim? And here we've also brought in this idea of where clause. So just like the old SQL, where account ID number is 4711. So maybe my account number is 4711. Please don't go and hack me now, everyone. But here's 4711, and we are looking for it. The account ID is that, and where there are 1 to 3 hops for the transfers. Now we can be explicit about that on the last one, where we then say it A along an edge to B, along another edge to C, along another edge, and it comes back to A. So it's a circular transaction that's gone to Jim, to Roger, to me. So that's how we can express that in the syntax. Pretty cool, really. Well, we need a tool to be able to write this in. Now we understand what it looks like. And thankfully, we can now use SQL Develop PGQL worksheets. So we can write it just like our normal SQL. If you're more a Python or a Jupyter person, a bit like myself, then you can also use it in there. And if you're a visual builder, there is also the graph visualization tool, which is really cool to use as well. So lots of different ways you can access this now you've learned your basic skills. So on that one, I think, Jim, we best show them what it actually looks like.
There we go. And
so
this is yours.
Here it is.
Sorry.
Yep. So here it is. We can now wrap all of that together and say select distinct from graph table. So that's what Jim built. We're looking for the matching. C1 is a purchase to P1 and C2 to that P1 as well. The customer's last name is Weasley and the product name is a Pixel13. So we're mixing and matching now that SQL and the property graph querying language all into one statement. Pretty cool. Oracle 23C can handle it all. Love it. So Jim, fancy showing us what this actually looks like in real life?
Sure. And before we move on to that, I just want to specify, yeah, this is the brand new thing, folks, right? To be able to say from graph table, open parentheses, here's my match statement, close parentheses. I'm essentially constructing this graph table called SH purchase in real time. And the main thrust of this is being able to do this live against your database. Think if you're doing this against live transactions. So that's the real thrust here. One other thing too, all these, if you're looking at the things that are in the C's and the brackets and stuff, don't get freaked out by C1. What does that mean? Think of them very much like table aliases. That's the easiest way to think about it, because that's what threw me the most when I was first trying to understand this over a year ago. But let me see if we can show you an actual demonstration. I know we can show it to you. Let me open that up and share it with you. And I'm going to pause several times through this demo because it goes through pretty quickly. We're going to go explore this feature. And of course, this is the one we've been crowing about. SQL PGQ support via the graph table clause. So I'm going to create a property graph. It's going to look very familiar to you because I'm going to pause for just a second here. You'll note that, yeah, that's the one we had just created in our earliest example. Basically, pretty much the same thing, slightly different column names. But what have I got here? A bank account, okay, right? The bank accounts table is going to be our vertex or nodes table. And I'm going to just pick three properties, the account ID, the name, and the balance. And then here, right, because an account would have a current balance. Here I'm going to pick a transaction ID as my key, and I've got a source and destination key. So there's directionality here, as Abby was talking about, right? I'm going from here to there. And notice the only properties I'm pulling off is source ID, source account ID, destination account ID, and amount. And by the way, this create property graph statement has not changed in 23C. I'm in SQL Developer. I hit the F5 key and it's done. Now, our property graph's ready to go. Let's go dive in and look for some suspicious activity. Let's find the top 10 accounts with incoming transfers. So I'm going to pause just for a second here. What do we have here? I'm selecting the account ID and I'm just using a dummy column, num transfers, count 1, right? So if for everything that I pull back, count it as 1. From graph table, this right here is the new stuff. What am I graphing? I'm calling this bank graph. Yeah, that's the name of my property graph that I just created. Match, directionality. Do we see that? The source node to a destination node. Remember, source and dist are nothing more than aliases. But the relationship, the edge that I'm interested in is bank transfers. And the only column I care about is the note, the destination account ID. I don't care about anything from the source. And then this is the graph table clause. But then the rest of this, my friends, it's just a regular old SQL statement. What am I doing? Grouping by account ID, order by the number of transfers descending. Why am I doing descending? Because I only want the first 10 rows. Just give me the top 10 folks that are doing the most transfers. And pausing one more time, 387. Oh, I think I remember that number. Yeah, that's one of the accounts that was being transferred to very heavily. 39 transfers. Oh, okay. So these are the guys that are probably doing the most transfers. They might be suspicious. They might not be. Let's take another look. Which accounts are acting as middlemen? And as I'm going through this, let me pause one more time. Think of what type of SQL statement you would have to write without this match clause. Let me tell you, it'd be ugly. And especially as we get into more complex situations. What am I doing here? Show me the account ID, which, by the way, is, the one in between via ID. I'm interested in who's in between. Who are the middle persons, if you will? We're going to call those the number in middle. We're going to count them up. And again, the only account I care about is the ones that are in the middle. I'm going to group by that, order descending, and our good old fetch first clause. I love that clause. Show me the top 10 accounts that are participating as middlemen. And some of the same columns are accounts, I should say, that were in the prior query show up here too. There's our old friend, 259 again. If you remember that graph I had, that picture, 259 was one of the primary ones. Let's move on. Okay, we know who those are. Let's see if we can figure out which accounts have had a 3-hop chain. But here's the key point, only starting with account 387. Notice our match clause, V1. So this is the source account that transferred. Here's that squiggly bracket. Technically, it's a left and right OG bracket, but yeah, it's a squiggly bracket. Yes, right. Not a curved bracket. So we're looking for all transfers where there have been 1, 2, or 3. 4 doesn't count. And I just want to see which accounts have participated the most in that. And I can see 387, because we started with 387. There's been a lot of people that 387's been sending money to. Are there any accounts within a 3-hop chain? A little bit more of an interesting statement. Source to source. Okay, so yeah, what I'm looking for is, are there triangles essentially? And note, exactly 3 hops. And as I show you the code examples in the next few cases, you'll notice only one thing needs to change, which is that thing inside the squiggly bracket. So this is going to show me the accounts that have 3 or fewer triangles, but they're all triangles, right? Because I'm ordering by the number of triangles. So 918, this account, for example, has a, I sent it to you, you sent it to someone else, they sent it to someone else, I'm sorry, and sent it back to me. So we're completing the triangle. Well, that's interesting. What about 4 hops? We're going to take a look at that in just a second. Within a 4-hop chain, note the SQL statement, one thing changes, that number. I didn't have to change anything in my code except, well, I changed the name of the 4-hop chains there. Okay, now I can see which ones have 4 hops from me to someone else, back to me. How about 5 hops? Guess what I have to change to make that happen? One thing, change the number from 4 to 5. And there's my answers. How about looking for other types of suspicious activity or narrowing down? what else is going on. How about let's find the first 10 accounts with 3 to 5 hops in their chain. Let me pause that for just a second. 3 to 5 right there. So again, 3 or 4 or 5, that's what's going to show up in this list. Notice I'm doing a select distinct account ID. These are the first 10. There are more, but those are the first 10. Let's isolate the top 10 accounts, right? So again, instead of just saying, show me the first 10, I want to find the ones that had the highest number of cycles. Show me those guys with a 3, 4, or 5 number of hops. And here's the end result in a moment. There they are, kind of quickly. Let's take a look at this. How about account 39? Are there any suspicious transactions? And by the way, I'm looking for any hops in the 1 to 4 range. That's what this is saying. And how many do I find? None. But I can change that. Let's add in some suspicious activity. Yeah, when I last checked, there were no transactions happening. But now somebody inserted into the bank transfers table 3 new rows. And here's the point. Well, so what? Who cares? Here's the query that actually lets me establish that. And what I find is that, oh, there's one of those interesting ones from S source to A to B to C. And notice there's directionality. You see that, right? And show me the individual columns. That's where these aliases come in handy, folks. That's the trickiest part, is understanding that. Why are there all these different aliases? Because they work. The point here is, why would I care about this? Well, because those transactions weren't there originally. But because we can use this match clause live, and by the way, if you go to this link, you can go directly to an OPG, or operational property graph example, essentially exactly what we just showed you. And you can experience the power of this for yourself, right? The point that I want to make on this, and I think that's the end of my demo, is that, and back to our slides, the point we want to make is that we did that operationally. We did that with live data, right? That one account had no issues until somebody changed things, until somebody added in a suspicious activity that we were expecting to look for, and now we can isolate that particular account. But wait, there's more, right, Abby?
There is. And I know one of the questions we've had while you've been chatting, Jim, was, are we going to show things like joins and stuff like that? There are so many different features in the property graph. You know, you can do joins, you can do, you know, we've basically started with the basics today, the 101, getting started with property graph, and really getting people into what is new in 23C that we would love you to go and have a go at and start exploring and having a go at. And it might be, you know, our next abstract is actually the more complex stuff like the joins, and also, you know, the other one is the algorithms in there. So if we just go to the next slide, Jim, inside here, not only can you just do the searches that we showed you, and that might be just us inquisitively asking questions of the data like we have done today, but actually we can look at this in terms of in-memory algorithms that are inside the database that you can use. So for example, path finding. What's the shortest path between me and Jim? You know, he's in the US, I'm in the UK, but how might I get a parcel to Jim in the quickest way? You could be looking at topology and cycle detections, so things that we've just looked at today. Strongly connected components. So who in your social network is strongly connected, so that if we wanted to get something out into the social media sphere, we get to that person, we get to that node, and it would be strongly connected across our network. Machine learning, so supervised graph-wise, all of those, you know, these are all in the database and you can do them. There is so much that can be done inside the database. It really is a playground of fun. But for today's session, it was more a 101 intro into the cool stuff in 23C that you can do.
Right. And some of these algorithms, I feel like I just went for my annual physical today, and I'm surprised my doctor didn't tell me you have a high risk for eigenvector centrality or something. I mean, some of these things are really unique, Oh yeah, you've got bidirectional Dijkstra, whatever that means. I don't know. Bellman, you have Bellman-Ford. I don't know. So some of these things are, very complex mathematical and really graphical, if you will, algorithms. You can't get to sleep tonight, Google them, or look it up on Wikipedia. First slide will probably do it. To wrap up here, though, a different way of looking at existing data. And remember, we didn't have to create anything different except for that property graph view, right? What that also means is that the concept of autonomous database, especially we talk about converged database, right? If your shop is someone's rattling around and going, we need to install, I don't know, Neo4j because we've got to start doing graph, you can go, wait a minute, we already can do that. Let me show you. Come here. Let me show you about the model clause in 23C. And by the way, except for the model clause, an enormous amount of this is already present in 19C. And if you have 21C, also in 21C. The new thing here we're talking about today is the model clause. By the way, if you really want to play with this, Graph Studio in ADB is super easy way to get started. And as Abby said, there are many other ways to hit this, but Graph Studio, especially for the visualization aspect, is marvelous. And wrapping up, I guess we do have some other things to take a look at here. The product page itself is right here. You'll get these slides, of course. Here are a whole bunch of people. Hans, the product manager supreme on this. Melly, I think we have a few other people here. Ryota as well knows a lot about this. We have a LinkedIn group, Oracle and Spatial Graph. And finally, we're going to take your questions. But just before we do that, we did want to remind you one more time about our April 9th through 11th conference coming up. And very quickly, I just want to mention that ODTUG Kscope will be in Nashville, Tennessee, July 14th to the 18th. I'm on the board of directors, and I'm supposed to have to say that. So I'm going to stop right now and go back to this wonderful slide. Roger, over to you.
So really, all that remains to say is we've got one more question that's actually sort of survived the panel. And it just says, when will it be possible to query spatial data with the Oracle graph?
Oof.
I think Melly's busy trying to answer it now, typing. But anyway, that's one there. If anybody wants to try and answer
I'm going to leave that to Melly. I think that's definitely a PM kind of question.
Okay, I think she's answered it. There we are. So, by the way, all the questions that have been asked and answered are in the Q&A panel. So, but really, all that remains to say is thank you. Do join us in person at the summit. There'll be a good bunch of people there. Hopefully, everybody on this call will be there. And it's one of my favorite times a year to actually meet and greet, and you have a really productive time. It's good, intensive learning. So, but thank you, Uncle Jim. Thank you, Dr. Abby. And I really appreciate you coming on today. Thanks for giving to our community. Appreciate it.
You're very welcome.
Thank you.